Okay, so on number 1, it wants me to find the measure of angle U, and this diagram has RSQ labeled and STU labeled. So I know that because RSQ and TSU are vertical angles, that this is also going to be 62 degrees. And I just need to find the missing value here of U. I also know that the sum of 3 angles in a triangle adds up to 180. So if I add 55, 62, and my unknown x together and set it equal to 180, I can solve for x and figure out the value of the missing angle. So I want to combine like terms. I have 55 plus 62, which will give me 117. And the x and 180 don't change. Then I want to subtract 117 on both sides. I get x equals, I do not know this one on the top of my head. So I'm going to use my calculator. I'm going to do 180 minus 117 gives me 63 degrees. So the measure of angle U is 63 degrees. Okay. Next one wants me to find the value of x. So similar to number 1, I'm going to take all 3 of my angles and I'm going to add them up to 180 degrees. So I have 40 plus 65 plus x plus 83, because this is the whole angle. And I'm going to set that equal to 180 degrees. Then I'm going to combine 40, 65, and 83. All 3 of those numbers are going to be added together. So 40 plus 65 plus 83 equals 188 plus x equals 180. Then I want to subtract 188 on both sides, and I get x equals negative 8. Number 3 is using the exterior angles theorem. This is the one where these 2 angles will add up to equal this one. So 75 plus 36 equals x. So I just have to do 75 plus 36, which gives me 111. Another way I could have done this, so this was using the exterior angles, or exterior angle theorem. Another way I could have done this would be using the sum of angles in a triangle and then using linear pairs. So I am going to give this a different variable inside right here. I'm going to give that y. So I could have done 75 plus 36 plus y equals 180. 75 plus 36 is 111. Oops, that should have been a plus y. Equals 180. Then I would want to subtract 111 from both sides. And I get y equals 69. So if I know that this angle measures 69 degrees, I could do 180 minus 69 to get 111 to get my y, because that equals a straight line. Okay. Same thing here on number 4. So I can do the angle sum to get my value of x. So I have 5x plus 2 plus 34 plus 4 times x plus 2 equals 180. First thing I want to do is I will distribute the 4 into the parentheses. So the plus 2 plus 34 stays the same. 4 times x gives me 4x. 4 times 2 gives me 8. Still equals 180. Now I can combine my 5x and my 4x. It gives me 9x. I have 2, 34, and 8. So that gives me 44. And I added those 3 numbers together. Still equals 180. Then I want to subtract 44 on both sides. I get 9x equals 180 minus 44 is 136. Then I want to divide by 9 on both sides. Which gives me 15.11. Did I do something wrong? Okay, so that's my x value. Then to find my y value, I just have to take these two and add them together and set equal to 180. So this would be the definition of linear pair. So I have 34 plus y equals 180, and then I just subtract 34 on both sides, and I get y equals 146. Okay, number 5 gives me two congruent triangles, and it wants me to fill in the blanks. So it wants me to say, it says angle B is congruent to, so angle B has one angle marking, so I want to find in the other triangle the angle that also only has one marking. This would be angle E. Line DE is congruent to, so DE has a triple line, so I want the triple line on the other triangle. That would be AB. Measure of angle E equals, so I have to figure out how many degrees angle E is. It's not labeled on the other triangle, but I have F labeled as 76 degrees, and I know A is 27. A and D are congruent, so I can move the 27 over here. And then I just have to solve for E, so I'm going to give it the variable x. So I have x plus 76 plus 27 equals 180. If I combine like terms, 76 plus 27 gives me 103. And then I subtract 103 on both sides. I get x equals 77. So my measure of angle E is 77 degrees. I didn't mean to make this congruent. Just equal. Measure of angle F equals, this one is labeled for me, 76 degrees. AC equals, since this is just an equals, it's just looking for the length. This is 3. Triangle ABC is congruent to. I want to label these in the same order, so it goes double angle, one angle, triple angle. So I'm going to go double, one, triple, so DEF. Okay. Number 6 tells me the two triangles are congruent, and it wants me to find the value of x and y. So because I know they're congruent, I am going to start off by finding the value of x. This angle right here is going to be congruent to this one because N and T appear in the same spot in the labeling of the triangles. So I can move 63 over to the other triangle. So I'm going to add my three angles together. I have 93 plus 63 plus 3x equals 180. Then I want to combine like terms. 93 plus 63 is 156. Then I want to subtract 156 on both sides. I get 3x equals 24. And I divide both sides by 3. I get x equals 8. Then I still have this y I need to solve for. I'm going to set LM and SR are the same. So I have 43 equals 3. And then instead of x, I'm going to plug in this value I just found. So times 8 plus y. So I have 43 equals 24 plus y. Then I subtract 24 on both sides. And I get 19 equals y. Okay. Here I'm given a proof. I'm told that the two lines are parallel. So let me find my highlighter really quick. So I'm told AC is parallel to BD. So that's going to be what I start off with in my proof. AC is parallel to BD. And then my reason is that I was given this. Okay. And I have to get all the way down to proving that angle 1 plus angle 2 plus angle 3 equals 180. So I know that has to be my very last statement. So I'm going to go and write that in my last slot of my proof. Helps if I write the same thing I was asked to prove. So, knowing that these two things are parallel, I'm just going to start off with 4, 2, and 5, make a straight line. So angle 4 plus angle 2 plus angle 5 equals 180. And this would be definition of a straight line. Then I know that because these are parallel lines, my yellow, this would be a transversal. So angle 1 is congruent to angle 4. And this would be by alternate interior angles. I cannot spell. And then I also have over here that BC is a transversal to my parallel lines. So I have 3 and 5 that are also going to be congruent by alternate exterior angles. Angle 5 is congruent to angle 3. Did I say exterior? I meant interior. Okay, and then this final statement is how I change this to this. So now that I know that 1 is congruent to 4 and 5 is congruent to 3, I replace those in the statement. So this 1 replaces that 4, this 3 replaces that 5. When you replace something, it's called substitution. Okay. Number 8 gives me a diagram of a house. And this roof, I'm supposed to prove that these two triangles are congruent. I have that these sides are marked congruent and that these are both right angles. I know that since they're sharing this wall also has to be congruent. Because this is a right angle and I have a leg and the hypotenuse congruent in these two triangles, the congruence theorem I want to use here is the hypotenuse leg. Remember, this can only be used with right triangles. Moving on. Number 8 is showing me that I have two triangles on a solar panel, and I want to prove that these two are congruent, and I have to figure out which theorem. So let me highlight so you can kind of see better. So on the diagram, they already marked these two sides congruent and these two angles congruent. I know that by the vertical angle theorem, those two angles are going to be congruent. I always think when I see a bow tie picture of vertical angles, because bow ties make vertical angles. So now I just have to label what triangle congruence theorem I have. I have angle, angle, side. That was the theorem we said that would work. So angle, angle, side is what I would use to prove the triangle's congruent here. Okay. If I take a look at number 10, it tells me a field researcher is using the following triangles to determine the distance across the river. And I have to decide what triangle congruence theorem proves these triangles are congruent. It gives me a side, and it gives me an angle. Because this is kind of a bow tie shape, if I turn it sideways, it looks like a bow tie. I can use vertical angles, so I have vertical angles there. Now if I look at this picture, I have angle, side, angle. So that gives me that the two triangles are congruent. And then looking at this picture, this length is 24 feet, so that means the distance between N and P, since they're similar triangles, is also going to be the same. So the river is 24 feet wide.